Alright, physics students, we're introducing a new concept called impulse. And impulse...
Let's go skydiving!
No, we're not talking about being impulsive. We're talking about force and time, force times time. Impulse is a new physical quantity, which is force and time together.
What's the secret to a good baseball swing? Well, unfortunately, I'm a Cubs fan, so that's something I've thought about quite a bit. Is it how hard you swing the bat? How much force, in other words, you apply to the ball? But what if you're a Cubs player and the bat makes contact with the ball for only a fraction of a second, right? Well, the student of physics knows that the secret to a good baseball swing is keeping the bat in contact with the ball for as long as possible. Both force and time matter. You can multiply the effect of a force the longer you apply it to something. So the longer the time interval, the greater the impulse. So swing hard, but also swing smart. You have to follow through on your swing. If you push, as it says, with the same force for twice the time, you're going to impart twice the impulse and produce twice the change in momentum. The key idea is that impulse changes momentum. The little triangle here is the Greek letter delta, and it's short for change in because physicists don't like to write that out, right? So impulse changes momentum. To put it simply, the harder you push on something, the longer you push on something, the greater the change in the object's motion. So then, when the force that produces an impulse acts for twice as much time, what happens? The impulse is not changed, doubled, quadrupled, halved. Pause the video and select your answer. And the correct answer was doubled. The impulse is doubled. Which brings me to the subject of soccer.
Now, Brother Matt and I are going to do an experiment to demonstrate to you the concept of impulse, which is sports related.
Alright, so we're going to talk about impulse again. Once again, what are the two factors? Force and time. Brother Matt, too, here is going to talk about the first factor, which is force. So the force which I kick the ball is going to give a change in momentum, so the speed of my ball. If I kick it with a small kick, a Brother Matt kick, it doesn't go too fast. Let's do the same kick with a lot of force. Let's do a Chuck Norris kick.
Chuck Norris doesn't need a lab coat.
There we go. Chuck Norris kick time.
So, as Brother Matt just demonstrated, the first factor in impulse, force, changes momentum. You apply a larger force, you get more motion, you get a larger change in momentum. But the other factor is time. So let's compare these two kicks. When I was not a star on my soccer team, this is how I might have kicked the ball. Okay? Not too much time. All right. Now let's see what the effect of a sustained force, a force for a longer period of time, is on the motion of the ball.
Safety first.
That's right. All right. Here we go. So the idea is that if you kick the ball, if you sustain the force, if you give it a longer period of time, you get a greater change in momentum. So I'm going to follow through. This is the idea of follow through, all right? So ready? All right. Here we go. All right. So we have this equation that shows the relationship between impulse and momentum, and we can play with it in various ways. We're going to take a look at 3 different cases in particular, and we've already been talking about the first case in which our goal is to increase momentum. Let's see. How do you increase momentum? Well, if you want to make momentum as large as possible, you simply apply the greatest force for as long as possible. It's that simple.
You can take these notes to the bank and print them, folks, or just write them down in your guided notes. That was a terrible joke. I'm sorry. Put these notes in your notebook, and just let me mention that the force that we're talking about can change during the time of contact, right? When you swing the baseball bat, you're not always swinging with exactly the same force, but we're just going to simplify things in class and ignore those variations. And now, a cannonball shot from a cannon with a long barrel will emerge with greater speed because the cannonball receives a greater average force, impulse, both of the above, or none of the above. What's your answer? Pause the video and select an answer. The answer is B, impulse. Why? Well, the average force in the cannonball is not going to change. It's going to be the same for the short and the long-barreled cannon, but the longer barrel is giving the force a longer time to act. It's like the difference between a good baseball player and a bad baseball player, right? The bad baseball player might swing the bat just as hard as the good baseball player, but the good baseball player knows that the longer you swing, or the longer you keep the bat in contact with the ball, the greater the impulse. Same deal with the cannon. The longer the cannon, the longer the interaction, the greater the impulse, the greater the change in momentum. We'll cover the next 2 cases in the following video.